Hi, this is Robert from Part Fusion. Last week I left off where I was going to try working with these 5000K lights and make another LED panel. So I have one of them here. So I made 10 more of these kind of pixels, I guess. And then I've mounted them on a strip board. There's a common rail and then connecting to a DC jack. So if I connect in 12 volts, a 12 volt supply, there's my one panel. It wasn't really bright enough, so I made a second one. So the light output of these two strips is about 900 lumens. It's kind of hard to see with my other overhead lighting. It worked okay. The only problem is that I kind of grew to dislike the blue color. So these are 5500 to 6000 Kelvin lights, and what I had kind of shown last week was a 4000 lamp that I have here, and I kind of overall prefer that. So I was able to do this with parts that I had available here at home. So I went to the local hardware store to see what the options were for light bulbs and light fittings. And what the local store was doing a sale on strip lights, a ridiculous clearance sale. So this is a 600 millimeter bulb, and it was on sale for €1. They also had 1200 millimeter for €1, and then they had 1600 strips for 50 cents euro. So I picked up a whole bunch of them. Wasn't sure if I was going to be able to use them, if they would work, if I could find fittings. So I didn't really get a chance to try them out before kind of having to commit. So these are 4000 Kelvin LEDs. So they were like my lamp here. And I kind of liked this color. This is the kind of color temperature that you would use in an office environment. So it kind of fitted. It's pleasing to work under. Not as kind of yellow as you would get for your kind of domestic lighting. So I went ahead and ordered some other LEDs for the fittings here in the room, so that I would have all of my lights at the kind of same color temperature. A couple of days later, and I finally managed to get to the electrical store here in Dublin, and I got some fittings, and I got to try out the LEDs, and I was kind of happy with the color, but I hadn't videoed them. So the one problem with these LEDs is that they're cheap. Well, I bought them cheap, but I think they're a relatively cheap one. So they actually have a lot of flicker. My overhead camera here is able to, it can kind of compensate for the flicker. But my mobile phone camera kind of sees some of the flicker, and I have a small kind of action cam here giving that I want to use for giving projection, an idea of what I'm doing, of the scene, and it has a lot of flicker. I should show you. I'll give a little clip of that. So I bought these LEDs with the likes of with the idea that I'd be able to use them, or that I would have to, or I could try and use them for parts. So that's what I was experimenting now. So I started breaking them open, and I found the easiest way to break them open is if you cut them with a hacksaw here, small hacksaw, and you cut through. You don't have to cut all the way, but if you cut almost all the way through, and on both sides, you can then put a screwdriver into your gap here, and then kind of twist it, and it will crack, and then crack it there, and then you just lever it off. The power controllers are kind of siliconed in. So here's the controller from one of the smaller bulbs, tubes. So it's 50 volts to 80 volts and 150 milliamps. So and then this is the controller of the largest one. So the power comes in from this end. It's then sent all the way across the board to the other side, and then the voltage regulation is done by this part, which then kind of goes back onto the strip of LEDs. So this is 55 to 85, 440 milliamps output. And then for the LED strips, here's the strips from the longest one. So there's 28 LEDs in series, and then there's 9 strips of LEDs. And they're on an aluminium backing. The tubes themselves are glass. There's a kind of a plastic coating on the outside, and the larger one has a kind of a plastic channel. On the smaller ones, the strips are siliconed on, so they're actually very difficult to remove. You have to break the glass off. But the larger ones are much easier to kind of get the strips out without doing too much damage to the glass, so these can then be thrown into the garbage or the rubbish. So I've just cut off a smaller piece of the strip. So there's one, your ground negative and your positive. So the positive rail goes all the way across, and the negative rail goes all the way across, and then here the positive connects into the first LED. Then there's a string, daisy chaining in series. All the LEDs are connected, and then at the last one it jumps over to the negative. So the LEDs are configured in series and parallel. There's no current limiting per LED or per LED string. So that means that they're, if kind of one LED goes, then they'll all cascade, and eventually they'll basically all go probably in quite quick succession. So I used the same idea that I had here. Is I thought I can't really do anything about the flicker using the existing arrangement. So what I've done is I've come up with the idea of making this type of circuit. So I can basically make up my own LED strips or my own LED light box. So I've got my AC power coming in. I'll use a standard voltage regulator, like a big one, like a 24 volt, maybe 36 or 48 volt, 4 amp, 2 amp kind of power supply. I'll then cut my board. I'll cut these strips into small segments of maybe about 10 or 12 LEDs. I connect those. Then I'll use the constant current regulator chip that I was using in this board to control the current per string. So that'll be much more reliable. In that mode, I actually can look at doing some dimming. I could add or I can switch them each string individually. I could add a switch into the circuit, or I could put an individual dimmer on each string, or I could put a dimmer on the whole string, because the current regulator here can switch at kilohertz. So here I have one of the strips that I made up, and it's a small segment. So this I can power off a 12 volt supply. I don't currently have anything like a 24 or 36 volt supply. So this is just using one of my constant current regulators. So that's 20 milliamps going through that. And if I connect that up to my 12 volt supply, I get a nice bright light. But these LEDs are a 2835, which is a kind of mid-power 0.2 watts, normally run at about 60 milliamps. So that's only a third of the current goes through it. So what I've done is you can actually put these constant current regulators in parallel. So I've connected two in parallel there. It's hard to see the difference in brightness between the two. And there, that one. So I've just got a small breadboard here. Here's my circuit where I've actually got 3 of the strings. So both of these have 40 milliamps going through. These top 2 here are 40 milliamps, and this one was only 20 milliamps. And it's not a huge noticeable difference. Like they're almost too bright to look at. But on the camera, I can't see a big difference between the 3 strings. I could add a third constant current regulator to get the full 60 milliamps through each string. You can mix and match, so you could have you can get the constant current regulators in 5, 10, 15, 30. In different packages you can get them up to 50 milliamps. So I can do a bit more playing around with these regulator chips to kind of see what brightness I can achieve, different arrangements, different layouts of the circuits. My filming desk is in the attic. So here's a rough sketch of the desk, and so there's the floor here. This is the side wall, and then the roof is sloping up over the desk. So it's a 1600 millimeter wide by 800 millimeter deep desk, and I would like to have the lighting across the whole of the table, like a uniform lighting across the whole table, and I like to be able to position the camera almost anywhere within that table frame. So what I've been looking at doing is making a frame like this that would kind of fit over the table. So I'm not sure the exact construction yet. So this would be floor standing frame, so it's that as the table, if I touch the table, that vibration isn't transferred into the camera. So it'll approximately 1400 millimeters high. So that's just enough to touch the roof without having the table have to be too far away from the back wall. And 1800 millimeters wide, and I would probably use bars, steel bars, to make this frame. I've actually, for this filming, I've actually mocked up the frame using, I'll show a photo showing it. I've used some plastic tubing and some dowel rods that I have had just lying around, taped together. These are clamped to the table, and then I have the lights taped to the rods, and I've used the cardboard from the LED tubes to form a kind of a shroud to reduce the glare into my eyes. I'll going to have a look at what materials I have available to make the frame and how to join the connections together. You know, maybe it'll be wood, some of it'll be wood, maybe it'll be all steel. Thank you.